Hey guys, Mr. Ground here, Chapter 11 portion of the Final Review IHD edition. So we're going to take a look at stats and probability. We're not going to go quite as deep into these ones as we could just because we've done these really recently. So we'll spend a little more time on Chapter 11, the first part, probability, and then we're just going to skim over the second part, statistics, because like I say, we just tested on that. So if you really need any extra help, you can just look at the review materials for the Chapter 11 stuff in the module, like just a couple spaces above this. All right, so first thing that we did was fundamental counting principle, combination, permutation, like how many different ways can things happen. We covered theoretical and experimental probability, what's supposed to happen, what actually does happen, probability from tables, independent and dependent events. This really means the card and dice problems, and then geometric probability. So taking a look at this, so fundamental counting principle, combination, and permutation. When it's fundamental counting principle, this means that we use this when you are choosing from different groups. So that would be like when you are, let's say we're choosing a shirt, a pair of pants, and shoes, right? To make an outfit. How many different ways can we make an outfit from those different options? So when you're choosing from more than one group. With combination and permutation, with combination, order doesn't matter. So generally speaking, if you're choosing like members of a team or people to go in a group, or like how many, how many like how many different ways could I pack a suitcase or something like how many different pairs of shoes could I bring on a trip or shirts could I bring on a trip, that sort of thing, where it doesn't really matter the order that you choose them, it's just they're getting lumped into a group. Permutation, however, order does matter. And this is typically if you are ranking something. So if we're looking at like ranking first, second, or third, gold medal, silver medal, bronze medal type thing, or like president, vice president, secretary, those are all super common ones in high school math. All right, theoretical and experimental probability. This is, theoretical is what should happen, experimental is what actually happens. So theoretical probability, this is like the number of successes over the like total possibilities. So like if we're rolling a single die, right? What's the probability of rolling a 1? Well, my success there is rolling a 1. There's only one way I can do that. And the total possibilities, there's 6 because it could be a 1, 2, 3, 4, 5, or a 6. Experimental, however, this is the number of successes over the total attempts. So if I roll that die 100 times and the 1 comes up like, I don't know, 16 times, it would be 16 over 100. I had 16 successes out of 100 total attempts. All right, the table ones. So looking at this, I just made a quick little table, 10th graders and 11th graders in Algebra 2 and FST. This is where we have to look at the way the problem is worded and determine, are we just looking at one of the rows, are we looking at one of the columns, or are we looking at the whole table? So if I said like, what is the probability that a 10th grader is in Algebra 2, I would only be looking at the 10th graders, and I would put 42 over 42 plus 15 is 57, so it would be 42 over 57. If I instead said, what is the probability that an FST student is a 10th grader, I could now be looking at just the FST students, and it would be like 15 over 15 plus 40 is 55, so 15 over 55. If instead I said, what is the probability that a student is a 10th grader in Algebra 2, now I would be looking at the entire thing, and I'd be saying that it is 42, the 10th grade Algebra 2 students, over the entire sum of the table, which in this case is what, 60 plus 115, I think. Okay. Oops. Yeah, so then independent and dependent events, cards and dice. I just have a diagram here. Make sure that you have screenshots of the card and dice diagrams, unless you're like me and you just, instinctively know this stuff. But you may want to have screenshots of these, so make sure to take that. And then as far as geometric probability goes, remember it is the area of the bullseye. Over the area of the target. And when we say bullseye, it could be any shaped bullseye, right? And so you're going to need some basic geometric equations, some area equations. So like for a circle of radius r, the area is pi r squared. For a rectangle, it is length times width, or length times height, however you want to think of it. And for a triangle, it is base times height over 2, or 1/2 base times height, 0.5 base times height, however you want to do it. It's all the same thing. Okay. All right, Chapter 11, Part 2. Now, this one I'm just going to sort of buzz through because, like I say, we just did this stuff. So you could be expected to, given a set of data, use GeoGebra or whatever you happen to prefer using to come up with mean, median, mode, max, min, and the range. And remember, mode is not given to you and range is not given to you, so you need to know how to do those. You could also be given a dot plot problem, something where you'd either have to create a dot plot or answer some information about a dot plot. Same thing with box plots. Additionally to the stuff that's listed up here, IQR and quartiles. Let's see, histograms are on the table, and then normal distribution, telling if it's a percent problem, and then skew right versus skew left. So the last thing that I would leave you with is make sure that you have a normal curve, a picture of this, so you know that you can use this to solve problems. All right, it's been a great quarter being your guys' teacher, so good luck on the final, and if you have any questions, email your teachers.